Hello Rama. Today we are going to learn how to create any like a rectangular volume. Okay. So for that we first need to open the nTopology software. Now we have opened it already. So let's move on. I will explain you how to create a rectangular like any volume. Suppose if we want to create any suppose cubical rectangular volume or where we can like a like a cubical lattice structure or cylindrical lattice structure or spherical lattice structures, and within the lattice structures we can use different unit cells. So today I will explain you how to create rectangular lattice structures using different unit cells, suppose strut based unit cells or surface based unit cells. So for that we need to select lattice type, a lattice block. Okay, here we have different blocks. So in that we need to select a lattice block, and later here further within the lattice block we have sub blocks, suppose lattice block and unit cell block and cell map blocks and conformal blocks, stochastic blocks, utilities block. Okay, so within them, just now we are going to use here. See, by seeing the shapes of this lattice block, we can easily understand that what kind of shape it is. Suppose we want cubical, then we need to select this rectangular volume. So there is a description regarding this. Okay, similarly we have cylindrical, similarly spherical, and also we have periodic lattice. Okay, so today we are going to use rectangular volume lattice. Let's select this. Okay, and yeah, suppose you want to we also first keep in mind, before creating anything we need to give the name of this file. How we can give? We can give by here even a untitled notebook. So title of this notebook is rectangular 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 volume volume lattice. Okay, this is our title. And suppose we want to add any description, suppose we want to add any comment regarding this. uh, the generation of the generation generation of a rectangular volume lattice, rectangular volume lattice. This is our comment description regarding it. So we are going to give section name as a rectangular volume lattice. Okay, this is our section name. We can create different sections. For now, for this section we have given name as rectangular volume lattice. Let's move on to create. So within this rectangular volume lattice, we have different input parameters such as volume and unit cells and unit cell size, frame, trim, unit cell parameter. Here we have only one parameter, and by default the unit cell size is 555 mm. Okay, it's all. Till now we have understood we have to give this input for. So where do we get all this input? So here volume means this volume can be anything. Suppose we have our mobile chip, it is in cubical form. We have our mouse, it has a different shape. We have our laptop, it has some different shape. We have some range, screw, bolt, any body. It is kind of either it is simple cubical or cylindrical or any spherical or any. See, these are simple geometry, simple 3D volumes. Suppose any complex volume, suppose curved complex volume, anything, they are considered as volumes. So today we are going to use like a box. Okay, box box volume. So we created the box volume, and once we selected the box volume, the box is generated. Okay, again it has some feature. Suppose this is our center point. So if you rotate by clicking the right button, this is exactly at the center of this our cube. If you want to change it, you can change it by using the parameter. It's up to you. So and the length, width. Okay, these all are. So let's see how exactly it is varying so that we can understand. So this is our length. Okay, and width is, this is our width. Understood? So let's keep it as it is. This is our box. Now we have created the box. So this is how anyone can create the box. Now we are using box. Suppose if you want to use cylindrical, you can just type here cylindrical. If you want to use any spherical, you can type spherical. Once suppose we are selecting a cylindrical shape, a cylindrical volume. So once we selected a cylindrical volume, the parameters, the input parameter with respect to that, they will change. Suppose cylinder, what are the parameters? Radius and height. Similarly, center point will be remain same, but the radius and height are considered as the input parameter for cylinder. Similarly, for spherical, at spherical we have the radius as well as the count of the longitude and count of the latitude. So those are the some input parameters we can find, and these are the some simple 3D geometries. But there are some complex 3D geometries. It is up to you. If you are creating any geometry from the SolidWorks or some any other CAD software, it is up to you. You can create them there and just import it here, and then we need to convert them from we need to convert them as a implicit body, because for example we have created a one CAD, any CAD. Suppose we have created one pen or one range or one bolt, nut, screw, or any kind of spool. It is up to you. Any gauge, any mechanical components, we have created them in any other CAD software. Suppose SolidWorks, suppose some Fusion 360 or some CATIA. It is some Autodesk. So it is up to you. You can create them in any other CAD software and just import them here and then convert into implicit body, and you can use it as a implicit body only. Now this the body which we are seeing, this is implicit body by default. Okay, this is all about the bounding box. Now we have filled the volume. Now the second parameter is unit cell. What do you mean by unit cell? Is there anything? Yeah, here we already seen. So here we have graph unit cell, TPMS unit cell, the world unit cell, and the world TPMS unit cell. So today we are going to select the graph unit cell. Graph unit cell has a one unit parameter, and it is also called as a strut-based one. Okay, so yeah, we have selected the graph unit cell. Now here again it has two input parameters. One is the unit cell, another one is orientation. So let's see what are the available unit cells within the unit cell parameter. Here we can see there are number of unit cells. Okay, today we are going to select the suppose we are going to select the simple cubic. Okay, simple cubic, it's up to you. Now we have selected. See, suppose we are going to minimize this. Simple cubic is selected and it is fitted into the bounding box. Understood? Now we just hold it. Once the moment we hold it, the unit cell block is got highlighted. It means we need to put our cell there only, our block there only. So now we have placed it there. Now the size of the unit cell is also 5 mm, 5 mm, 5 mm. The box unit cell is also 5 mm, 5 mm, 5 mm. Understand? So now we want to change the size. Suppose 2, 2, 2. Okay, this is we have changed. Now let's frame we can give as a optional. So today we are going to keep it as it is. The thickness, yeah, this is the one of the important parameter. Let's see some random value, 0.5. Okay, yeah, this is how it got generated. It means now we have given actually our total unit will be 10 10 10 na. So that's why the unit cell size is 2 2 2 2. So due to that 5.5 mm thickness, suppose one thickness, how does it look? Now here it is, see, so thickness got increased. Suppose um, unit cells now 5 5 sorry 5 5. See, now it is exactly fit into the our lattice structure. So this is how we got generated. Even if we create a 1 1 1 unit cell size, let's see what will happen. Total 10 unit cell must be generated. So let's wait and wait until the structures. Okay, oh, it is too. Okay, so now we have generated this. We can turn off the trim option. So yeah, no point of that. It's okay. This is how we can able to generate our lattice. Suppose I want to make, yeah, these are all the cubical lattice structure. Total how many unit cells we have? We do have one, two, suppose let's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, total we have 10 unit cells. This is all about. I hope you understood. Suppose now we develop the one algorithm. Suppose somebody want other unit cells, then they can choose body centered cubic. They can choose it as a body centered cubic. Yeah, this is how I can show you 2 size. Yeah, see how beautiful it is, isn't it? Yeah, you can zoom it and see how beautiful it is. Now, if you want to place centered cubic by keeping unit cell size 222 and unit cell parameter, the thickness is like as it is. See how beautiful it is. Yeah, so let's go ahead, and that's it for today. I hope you understood. So today we have learned how to create a rectangular volume lattice using simple cubic unit cell, a face-centered cubic unit cell, body-centered cubic unit cell. I have shown you, so I hope you understand. You understood this. Okay. So with this, I am. We can go and save the file. Go to the file and save as. We can save this as like a rectangular volume lattice. We have saved it. So okay, then bye. We can meet in the next lecture.